Now let's solve another question from GATE 2020 Mechanical Engineering Set 1. The question says that the truss shown in the figure here has 4 members of length L and flexural rigidity EI. So you can see that 1, 2, 3 and 4. You have 4 members each having length L and flexural rigidity EI. Okay. And one member is having length L root 2 and flexural rigidity 4 EI. This is that member. Length is L root 2, flexural rigidity 4 EI. It was also possible that question could not have given L root 2 and it would have told you that this angle is 90 degree, this one, that it's a right triangle. So using the Pythagoras theorem you can calculate that. Here it has given L root 2, so it clearly tells you that this is a right triangle. Both of these are right triangles. Okay. The truss is loaded by pair of forces of magnitude P as shown in the figure. So you can see that at this and at this end we have P force acting at 45 degree from the horizontal. Okay. It is asking you the smallest value of P at which any of the truss member will buckle. 4 expressions are given. The best one, the correct one you have to choose. Look, as you will keep on applying the force P, we know that the force applied on truss is distributed across the different members, right? So as we apply the load P or the force P, it will be having certain distribution within the truss such that each of these members will be acted upon by some force. Okay. It is saying, the question is saying that for what minimum value of P any of these members are going to buckle, because if you keep on increasing the loading on truss, what will happen? The load which each individual member is resisting will also keep on increasing. And if you further increase the value of load applied, then a point will reach where any of those members can buckle as far as this question is concerned, right? So that load you need to find out, the external load P at which any of these members, of these 5 members, will buckle first. Alright, it's a very simple question. Look, the question, the diagram, if you look at it, it seems that there are 5 members, 1, 2, 3, 4, 5, right? But in terms of load, there are effective 2 members only. Why? Because whatever will be the load in this member of length L will be the same load in this L, in this member L and in this member L. How? Look, concentrate on this particular joint. Load P is acting and L are inclined at symmetry to this load, right? This is the line of action. This is the line of action of this load. And about that line of action, both of them are symmetrical. Correct? Both of them are inclined at 45 degree, one on one side, other on the other side of the line of symmetry. They are mirror images about the line of action of this load. So both of them are going to have the same value of load. Same is true here also. Both of them are going to have the same load. And since both of these loads are also same, so these loads means these loads in the individual L are also going to match. So ultimately all of these members are going to have the same value of load within themselves. Okay. So you need to calculate that value and the load acting in this L root 2. So these two values of load you need to find out and then treat them as columns. You consider that you have a column of this length L and some load is acting on that column which we will calculate, and for what value of load that will buckle. And similarly this also you treat as a column and for what value this will also buckle, and minimum value of them will pick. Again I am saying you don't have to calculate this for all of them. Visually also you can see you don't even need to calculate that. Okay. If you will start calculation, you will automatically realize this, but visually also you can tell that alright, you don't have to find out the load for all of them, only 2 loads you need to calculate. Anyway, let's start the question, let's discuss the question. So we have named these points A, B, C and D, and if we consider the free body diagram of let's say point C, then this is how it is going to be drawn. Correct? This is P, B, C, this is P, C, D, this is 45 degree. Alright. Now let's apply summation fx is equal to 0, summation fy is equal to 0 like we do. Summation fx is equal to 0 is going to give you p cos 45 is equal to pcd. pcd is equal to p cos 45, which is equal to p by root 2. Correct? And similarly, applying summation fy is equal to 0 will give you p bc is equal to p sin 45. Correct? Sin 45 is also 1 by root 2. So it will be p by root 2. So as I told you initially that both PCD and PBC means in this member and in this member, both of these members will be having the same value of load. Correct? And I told you if you apply this same funda at point A also, there also you will get the same thing. AB and AD will also be having P by root 2. So basically all these L length member have the same value of load, which is P by root 2. Now you need to find out the load in this member and then compare them. But let's pause here and think what type of load is acting in these members of length L, whether it's a tensile or compressive load. Look at it. In the diagram we have represented that to be a tensile load. Now those of you who are getting confused that this force is acting like this, so it will compress BC, they have little weak basics, because I have already covered these silly mistakes that why some students confuse between tensile and compressive in the FBD of trusses. So if you are falling in that category, you need to brush up your basics a bit. This force PBC which we have shown here for the joint C tells that in the member BC force will be tensile. We have drawn the free body diagram of joint C and not the free body diagram of the member BC. So when joint C is having tension along BC, it means that if you draw the free body diagram of BC, it will also be having tension. I am not going into the detail of that right now. Okay, so coming back to the point that BC, CD, AD and AB, all of them will be having plus P by root 2 force, which is a tensile load, as you can verify from the direction as well. Now, can buckling occur as a result of tensile load? No. The question is about buckling, right? The question asked that for what minimum value of P any of these members will buckle. And these members of length L are not going to buckle because they are not getting compressed. So the only possibility of compression occurs in the member BD. We have not verified it yet. We are going to verify that in next step. But that is what we can easily conclude. And if you look at this question, if you try to feel the question, then also you will understand this. This is how this square is, and you are pulling it like this. So what will happen? AC will try to go far and BD will try to come close, right? It will, if I exaggerate the deformation, so due to the effect of P, it is trying to get stretched along the diagonal AC, and it will automatically get nearer or compressed along BD. So BD is definitely going to get compressed, and these, as you can, I'm sure you can feel that these members are getting elongated. Alright, they are, even if they are not getting elongated, let's not go into deformation, but definitely they are having tensile load at this point. Correct? That we have concluded mathematically also, and that you can feel also. So ultimately, out of all the members, all the 5 members, the only member to be considered is the member under compression, which is BC. Rest all members are not under compression. This is something which is very tricky to understand in a question. You may miss this concept altogether. That is somewhere where students can make silly mistakes, right? They can carry on with the calculation without even considering that question is talking about buckling. For buckling to occur, the type of load should be compressive, correct? So this is the funda where some of you might have made a mistake in the examination. Now, coming to find out the value of load acting in BD, what we can do? We need to draw the free body diagram of joint B. Okay. Now, this is under tension, PBC, and PAB. And definitely PBD is under compression. So for compression, we have to draw it like this. PBD. Alright. Again, I'm not going into the basics of trusses here because that's not what we are discussing here. So what are the small mistakes that you can do in drawing the free body diagram? That I'm not discussing here. Alright. So if we are considering BD to be inherently compressive, this is how we are going to represent that in the free body diagram. Alright. And this we can definitely push ahead and represent like this. So this is PBD. Okay. Now applying the same summation fx is equal to 0, what you will get? PBD, and P here is already compressive. We have assumed that to be compressive. So don't expect a negative sign there. So PBD cos 45 in this direction is equal to PAB. And PAB we concluded was P by root 2. And cos 45 1 by root 2 will get cancelled. So ultimately you will get PBD is equal to P. So in this member, the same load or force P is acting directly. So as a result of that force, how much will be the critical load for buckling? Pi square EI by L square. Okay, but EI in this case is 4 EI. So this will be multiplied by 4. Length here also, length effective is not L, rather it is L root 2. And since, as I told you, that all of them are hinged, right? The members of truss at both ends are hinged. So for a hinged joint, the actual length is equal to effective length. So effective length is L root 2 itself. So if you square that, it will become 2L square. If you cancel it, 2 will be in the numerator, 2 pi square EI by L square. This is the P critical, means the amount of load that is required to buckle it. And in the section BD, what is the actual force acting? Actual force is equal to P itself. So if you keep on increasing the value of P, the same P will be reflected in BD. And that same P is going to buckle it, right? That same force is going to buckle it. So PCR can be written as P itself for this case. And if we write it as P, then this is the expression that we have got, that P is equal to 2 pi square EI by L square. And if you look at the option, this option 2 pi square EI by L square is the correct answer for this question. Okay.